All right, welcome everyone to the Energy Data Insights on AWS for OSDU Data Platform Enablement webinar series. We've been kicking this off for the last couple years, and this is our second webinar for 2025. For those of you who don't know me, my name is Yuri Gubanov. I'm the Energy Partner Solution Architect with AWS, primarily working on upstream and subsurface workflows with a focus on OSDU and energy data platforms. We have an exciting agenda for today. We will do a quick introduction and recap of these webinars that we've been doing for a couple of years now. And then we'll have two exciting partner presentations. We will start with OSDU Integration, Bridging the Gap Between Vision and Reality by Petrosys and Interica, followed by EDI-IQ and Transformer and New Features Preview by Petrabytes. I will let the presenters from each of the companies introduce themselves and their companies when it's their turn to present. And each presentation will take about 20 to 25 minutes plus Q&A. Just a reminder, the session is being recorded. You can either unmute yourself during the time for questions and ask the questions live, or you can use the chat and ask the questions through the chat. The chat is not being recorded. Finally, we'll wrap up this webinar with a quick overview of the upcoming events, Q&A, and survey. And I would really appreciate if you give us some feedback and stay around for the survey to provide us some direction on what you would like to see in the future sessions. All right, so I have a link here and I post it in the chat once I get a chance to go off the presentation mode. We've been doing the EDI webinars for a couple of years, like I said, and all of these webinars are posted in our AWS Energy-Tech-Talks YouTube channel. So the current webinar that we're going to do assumes that you have some familiarity with OSDU Data Platform, Energy Data Insights, and we focus on some new partner capabilities on this webinar. So two presentations, like I mentioned before, by Petrosys, Interica, and Petrabytes, will dive into that. If you're not super familiar with OSDU and this is your first time attending one of those webinars, then I highly encourage you to go back to this Energy Tech Talks channel and review our prior videos, which give the introduction of OSDU and Energy Data Insights, its capabilities, and that would kind of help you to get up to speed and catch up with all the functionalities that we're going to be discussing here today. With that, I will turn it over to our first presenter, Kevin Ward from Petrosys Interica. Kevin, are you online?
Thank you, Yuri. Yep, can you hear me okay?
Yep, I can hear you okay. Do you want me to present for you, or would you like to kind of take over the screen and present yourself?
If I can share my screen, that'd be ideal.
Okay, sounds good. Let me stop sharing and feel free to take it over.
All right. All right. Can you? Oh, there we go. How is that? Can you see my screen okay?
Yep, I can see your screen.
Perfect. So I thought I would start with that.
I joined the presentation just now.
I have to apologize. My camera doesn't seem to be working, so I thought I would just start on my LinkedIn page so you can see what I look like if you're curious. So this is me here. My name's Kevin Ward. I'm the VP for Petrosys and Interica in Europe and Africa. My background's in geology and petroleum geology. And more recently, I've been involved in the creation of the new exchange product that we're creating at Petrosys and Interica. And so as the product lead for Exchange, my job today is just to take you through how that product can help sort of bridge this gap between vision and reality for the OSDU. So that takes me on to these slides here, which I'll share and run through that. So I have a few slides and then a couple of videos showing you how this product called Exchange actually works. So to give you a bit of history as to our involvement with the OSDU platform, Petrosys and Interica joined the OSDU in 2019. By 2021, we had some initial integration in the OSDU. Firstly, on our one of our other products called Interica OneView, which is all about archiving of data. So that archiving solution integrated with the OSDU in 2021, and then later in 2021, we wrote some code to to do the initial sort of a version of Exchange connected to the OSDU for well data. More recently, we've been working closely with AWS, and we deployed Interica OneView on AWS's EDI platform. And then last year, we also joined the OSDU interoperability work group. So we've been very heavily involved in this sort of concept of enabling OSDU to actually work in practice by connecting off different applications and data to the OSDU ecosystem. So to give you just a bit of summary, I know most people on the call are probably very familiar with what OSDU is trying to achieve, but just to set the scene for my upcoming slides, the OSDU data platform is designed to break down silos across the energy industry. We have seen from working with many customers that they feel their data is held hostage or locked in silos within applications, and they want to liberate that data from the applications and then use that data wherever they need that data most. So enabling this open standard-based access to subsurface and operational data and supporting a cloud-native workflow and modern data ecosystem. So the key benefits really then are you get that improved collaboration across operators and partners and vendors, faster decision-making, and then that long-term agility and sustainability and digital transformation. So that's what the OSDU, that's what its purpose has always been. That's why it was founded. Now, the reality check really here is that adoption is not automatic. The applications in the industry today are not automatically aligned to the OSDU. They don't automatically read data from the OSDU. So that makes today's workflows a real challenge. I think even after 5 to 10 years of the OSDU, we're still in that situation where applications are not able to access all the benefits from the OSDU and from AWS's EDI ecosystem because they were not created in a time when the OSDU existed. So these existing desktop tools and data models are not naturally aligned with the OSDU. Now, what we're trying to get to is we need that data to flow smoothly across those applications. There's always frequent format and application changes that create this disruption. Users need the protection from these changes because users need to continue their day-to-day work just now. They can't simply pause and wait until all of that has been done. These established systems still need to connect to cloud-native platforms without requiring costly rewrites. And I think that's a really important point, is that these existing systems are being asked to connect with this cloud-native OSDU platform, but that comes at a huge cost to rewrite those applications. And so there's a commercial element to making OSDU a success. And then finally, data quality and governance must also be maintained, even when we're moving that data. And so this is really where we see Petrosys Exchange bridging that gap between the OSDU's very important vision, but also the operational and commercial reality of the situation. So over on the left-hand side, you've got your desktop workflows. Most of the current powerful applications in the industry are all still desktop applications. I'm thinking things like Betrayal, Decision Space, Kingdom, Paleoscan, IP, JSON, Hamson, Russell, RockDoc. All of these big applications were created before the OSDU was even thought of. These desktop workflows are now being, or these desktop applications rather, are now being asked to connect with the OSDU cloud platform, so the Energy Data Insights. And so we need to create this bridge between these two to make them work. Petrosys Exchange provides this bridge between today's workflows and tomorrow's OSDU vision. And that final sentence on that slide there, to focus on the data, not the applications, that was something I just wanted to add, because that's really where I personally see this vision for Exchange. I think currently in the OSDU community that the focus has been on the applications. The sort of logic has been, well, let's convert the applications to read to OSDU data live. Let's convert all of the applications so that we can support OSDU. But the reality and the cost of doing that is quite substantial. And Anecdotally, I spoke to a vendor who'd done some research into this and said and estimated that it could be as much as $40 million to convert their application to run natively on the OSDU platform. Now that's an extreme example, but if you consider it's a significant cost for all of the vendors, all of the applications that I mentioned, you're having to convert all of those applications to no longer run on the data formats they were created for, but to run on this cloud native format that we've created. That's a significant cost to these vendors. That cost is then passed on to the operators, which then becomes a significant cost and a significant burden to the industry. And so what we're trying to see here is let's focus on the data, not on these applications. If we can make the data work and not have to convert every single application, then we can make this an operational reality and make it a commercial success. And so this is where Petrosys Exchange comes in. Petrosys Exchange is all about revolutionary integration. We've created connectors which can integrate data seamlessly, both subsurface and spatial data, across a range of the best known and most used applications in the industry. So you can see some of these logos on the screen here. Applications like I've mentioned so far are all there, but importantly, OSDU also features on this list here. And so these connectors allow enhanced efficiency. They streamline your workflows and allows or reduces manual effort to move data between these applications or to move data to connect to the AWS EDI environment. That allows you to make informed decisions, and the better choices with more comprehensive and up-to-date data sets. And we're continuously developing this application. So we're continuously developing it to work with AWS EDI, OSDU, as well as connect to more data sources and data types. So there's a couple of case studies that we have just to show how this is working in practice. The first of these is an operator. It's a mid-size operator who were working in a joint venture with a super major. So the super major was aligned with the OSDU, but the mid-size offshore operator was not aligned with the OSDU. And they needed to access well data that was stored in the OSDU inside AWS's Energy Data Insights. So the challenge for that operator was that they needed to use that joint venture partner's OSDU data, but they were not an OSDU member themselves, and they didn't have any native access mechanisms. So the solution was to use Petrosys Exchange. They used Petrosys Exchange to connect to the OSDU platform with the provided credentials. They could filter and extract the relevant data types, the headers, the tops, the surveys, the logs. They could then sync that data to Petrel, which was their interpretation system of choice, and they would very carefully use the merge and overwrite controls so that they were only updating Petrel with new information, new data. So the result was fast and secure governance and compliant data transfer, and this reduced manual handling and improved that collaboration between those partners. Schematically, this is what the workflow looked like. So over on the left-hand side, all of the data was stored in Energy Data Insights and the OSDU platform format. And they wanted to get that data over here into SLB's Petrel product. It could have been other products they were using, but in this example, it was Petrel. And they used Exchange as that bridge to get the data from OSDU, sync it into their Petrel project, do what they needed to do inside Petrel, and then sync it back to the OSDU so their joint venture partner could also access the results. So to show you that in a video, we've got Petrel open here. This video is just showing we launched the Petrosys Exchange application. We're now connected to Petrel, and we can launch a new project exchange. And you can see on the output side, on the right-hand side, we just select that we want to move the data to Petrel. And on the input tree on the left-hand side, we select that we want to connect up to the OSDU. This is where we put in the credentials. So we connect to the AWS environment, put in the right credentials. And we're now connected up to that OSDU platform. You can see here there's over 1,000 wells in this OSDU instance. There's some handy filters and various other things you can do to speed up the process, but we effectively find the wells that we're looking for, toggle those on, And you can see on the right-hand side, those wells now appear in green, showing that once we do that transfer, those are the wells that are going to end up in the Petrail project. On the left-hand side, you can see there are merge options. So you set those so that we're only updating the new wells. And you can see from the Petrail project in the background, those wells have now been moved into the Petrail project, including any coordinate reference transformations that need to occur, any attributes, any logs, horizons, directional surveys, all of those get moved into the Petrail project. And we can now use those wells natively within Petrail. Now, once we've done some stuff within Petrail, we've achieved our workflow, we can then move the results the other way. So we select Petrail now as the input, and we now select OSDU as the output. Again, connect up to AWS's EDI environment using the right credentials. Select the wells from the Petrail project that we want to move, including any tops, any zones, any log curves that have been created or changed. And we then select those to move into the OSDU environment. And you can see those are the wells that we would move there. These workflows as well can be saved and reused. So even though we're seeing them set up in this video, once we've set them up once, we can then save that and rerun that and just pull in the changes as needed. So that was the first example. If I move on to the second example here then, the next was a case study with one of our partner companies with GeoSoftware. GeoSoftware provides advanced seismic reservoir characterization solutions, and they were responding to an increased demand for OSDU aligned capabilities from their users. And so GeoSoftware worked with us to embed Petrosys Exchange within their applications, Hampson Russell and JSON. So the challenge for GeoSoftware was that they had a growing client demand for OSDU workflows. They needed to enable data access. And as I mentioned at the start, one of the options they had was to completely rewrite their applications to run on OSDU rather than their native data formats. They realized that there was limited appetite internally to commercially put in that major internal development effort, with no guarantee of how performant the output would be to those applications. So the solution was to embed Petrosys Exchange within Hampson Russell and JSON that provides direct connectors to the OSDU platform and makes those applications OSDU compliant. The result is that we delivered OSDU compliance functionality quickly and efficiently. Those improved workflows makes it efficient and data accurate for those users. And importantly, it freed up their development resources to focus on what they do best. It focused their development resources on making the products better, making their core features better, rather than focusing on rewriting applications to run on different data formats. So another schematic just to show you that here. So GeoSoftware's Hampson Russell and JSON software, they needed to connect it to the OSDU platform and to AWS's Azure Data Insights. And so they use Exchange as the bridge to get data from GeoSoftware's applications into the OSDU and then back again into those applications. So just another quick short video to show you this working. In this case, we're now inside of the JSON application. And you'll see inside of the JSON application now, if you go to the data tab, there is a Petrosys Exchange option embedded within there. And the first thing we'll click on is the well import option. And you can see by default, the output is automatically set to JSON. We now just need to select the input source. In this case, it's OSDU. We connect up to the EDI platform using the right credentials. And you can see in this case, I think there's about 6,000 or 7,000 wells in here. So again, we just now need to select the individual wells that we're looking for, either manually looking through them or doing the handy filters that are there. Again, on the right-hand side, in the JSON application, you can see that the wells that are not currently there are shown in a green color, showing that these wells will be transferred into JSON. We'll select the other data types we want, the curves, the logs, and then we click on run, and it pushes those wells inside of JSON. If we go back into the JSON workbench now and have a look for those wells, we can see that those wells are now available to the user to use those wells natively as needed. including all of the coordinate information and any tops, deviation surveys, log curves as required. And the user can now use those wells and do any interpretation or make any changes to those wells as needed. And when they've done that, we can now go the other way. So we now use Petrosys Exchange to do a well export. JSON is now populated on the input tree on the left-hand side. So we need to specify that we want to move those wells back to OSDU. Now we could move the wells from application to application, but here we're focusing on syncing those wells back to the OSDU platform. We expand the tree, we can see the 6,000 or 7,000 wells that are currently within that AWS EDI environment, and we select the wells that we want to move back there. And you can see down the bottom, we've got options to do the merging and syncing as well, so that we don't have to overwrite. We can simply merge and append the changes as needed. And that is the second workflow. So I'll just quickly summarize then what we've been talking about then and why Exchange is valuable. So the reason that Exchange is valuable is it allows you to use your application seamlessly for their strengths. And that's really what the OSDU has always been about. It's about separating the data from the applications so that you get to choose which applications suit your workflows best and not feeling like your data is held hostage within those applications. So you get more dollar value from your specialist applications. It allows you to move to AWS's EDI environment very easily. So Exchange makes your subsurface applications OSDU compliant. And if there's a connection that we don't currently support, we'd love to hear from you. We'd love to add that to our roadmap. And we're giving Exchange a lot of development resources just now, so we'd love to add new connections if they are needed. We have around 15 data sources, but as I say, it's growing, and also not just data sources, but also data types. We've focused on well data for OSDU initially, but there are lots of other DDMSs and data types that we can connect to and we'd look to develop along with interested partners. And there's no need for there's no need for isolated workflows. Petrosys Exchange combines these into a single transfer tool. And as I showed in the video, you can save those workflows so you can have multiple transfers going and you can rerun those workflows in an automated fashion once a day or once a week whenever you need them to sync the data as required. And we've been continuously developing software and links for over 40 years now. So as I say, we're giving Exchange a lot of development investment at the moment and keeping all of those connections up to date. So thank you very much for listening. As I say, my name's Kevin Ward. I've got my details on the screen there if you want to reach out to me directly, but I'm happy to take any questions just now.
Kevin, thank you for the excellent presentation. There is one question in the chat. It's regarding to the demo that you showed with Petrel. And the question is, does it only support well data or any other data types? And are you reading this well data from Wellboard DDMS or core services?
Yeah, okay, so yeah, good question. So at the moment, specifically for OSDU, it's just well data. We support other data types going directly from application to application. So seismic, moving a seismic survey from OpenWorks to Petrel, for example, we support. But thinking specifically about OSDU, we've started with wells because that was the most advanced DDMS, and it is the wells DDMS that we've been working with. We're now looking, at the sort of the other things like the reservoir DDMS and other things, and I think surfaces has been mentioned as one of the key things for us to support next. So at the moment it's just wells for OSDU, but if there's something in particular you think we would need to support urgently, we'd love to hear from you.
Right. Thank you, Kevin. Any other questions for Kevin before we transition to Sasha in the next presentation? All right, Kevin, thank you again for the great presentation. Sasha, I'll turn it over to you if you want to go ahead and present. Oh, Kevin, and I think there's one more question just came in the chat. If you can go ahead and address it. Yeah.
I will do. I'll enter the chat. Yeah, sure.
Yeah. All right, Sasha, I'll turn it over to you. Feel free to share the screen and start presenting. And if you can give us a quick introduction of yourself and Petrabytes, and then take it away. You have about 25 minutes or so.
Yeah, thank you all. My name is Sashi Gunturu. I'm the founder and CEO of Petrabytes. So I've been in the industry for almost 25 years. So I used to work for Geomechanics International and also with Baker Hughes. And then we have been partnering with AWS on the energy data insights. So can you all see my screen?
Yes, we can. It's not in the present mode. It's kind of in the outline mode, but it's visible.
Yeah. We are good. Yeah. So these are the topics I'm going to go through, mainly focused on the data quality.
Hold on, Sasha. I think if you switch to present mode, you're still showing the other screen.
Okay, one second. One second, please.
And I guess while Sasha is checking screen, Kevin, there are a couple more follow-up questions in the chat if you don't mind addressing those.
One second. Yeah, can you see my screen?
Yeah, looks good now. Yeah, what's new in EDI-IQ and Transformer? Yeah, showing up full screen.
Yeah, sorry about that. Yeah. So we'll be focusing purely on the source data analysis and also looked at the seismic sub project. So we have been working with a couple of operators on the seismic aspects, and then also on the data enrichment, how pre and post data enrichment, and also the custom schema, because not all of the data is there in OSDU. So we'll show an example of how we look at geothermal gradient, and also from the consumption point of view, the persistent collection, how we can capture the data and then allow for applications such as Petrel to consume. And also I'll briefly talk about how we are getting into the reservoir monitoring with OSDU, and also updates on the data visualization. So quick overview from the data quality point of view, right? So if you look at as the data grows, especially on the seismic side, we have divided the whole workflow into 4 parts. One is how good your data is, because when you have terabyte, petabyte scale data sets, you have to process lots of data. So before you get into any kind of OSDU data processing, we now can do a comprehensive source data analysis of all the data, like how good the headers are, the binary header, the EBCDIC header, all of that. We can do a very detailed analysis on your source data. And then we define a very detailed quality score. And then we go into the data preparation and the data processing, where we look at the byte positions, we look at the metadata, we do all the conversions, and then during the process, we do all the technical assurance and we validate it. And then at this point, you can also enrich the data and then ingest into OSDU. As we are going through, we also capture all the data lineage. So more detail. So what we have done is, because each of the data types are different, like how you look at the well data is different than how you look at seismic data. So we have data specific business rules that we have gone into extreme detail, like all the way from seismic, geobodies, geology, reservoir, core data, all of that, including the real time, like we like I think in Amsterdam we presented the real time streaming as well. So all of the data will have a very detailed data analysis before you go into the OSDU data ingestion process. So first check, these are some of the business rules that we use for all your EBCDIC header. So there is a very comprehensive list of business rules. So essentially what we are doing is we are scanning the entire source data and we are giving a very detailed analysis of all the data sets. So here we can look at all the EBCDIC header, the text headers. We look at the binary header, we look for the segue versions, we support all the different versions, and we go into more detailed analysis of the byte positions and all of that. And then we look at what kind of revisions we have, whether it is 2.1 or 2 or all the different versions of the seismic. And here is another example how we can enhance the data quality also. For example, you have a 2D seismic and there are some missing headers which has a low data quality. So we can fix those and we can revalidate and improve the data quality and ingest the data. So the improvement of the data quality can happen before or after the ingestion. Okay. Um, so once you have done all the analysis of your source data, next step is the byte position detection, because that's what you need for any conversion into either VDS or MDI. So we go through a 7-step process where we look at the header extraction, and then we look at all the byte positions. Using the transformer, we can extract all the key values from the text header. We look at the UTM coordinates. We do what is called a wave-4 pattern, where we look for the correlations between inline and crossline, and we do a detailed scan. So at the end of this process, we have a comprehensive understanding of all your byte positions, X and Y locations, and the UTM coordinates, and then we ingest into OSDU. Okay. So here is an example of the wave-4 pattern where you see a pattern between inline and crossline, but you see it slightly off, and then we get for the final uh, um, position alignment. So this is a process that we go as a second part of the workflow. Once you do the source data quality, then we look at the patterns, we look for the byte positions. The next step is we simply extract all the data with the business rules. So we go through a more comprehensive business rules. So now we're at a point in phase 3 where you have all the data is good, we have the byte positions. Now I'm ready to process the data into OSDU. So we go through a comprehensive check of the schema compliance, the reference data checks, and then you have look at all the mandatory attributes. We look for the completeness of the data. We look for the data conformance, and we look for entitlement obligations and also look for any duplicate data checks. So once you have it, we can go through. Sometimes you might want to add more additional rules. So we have a JSON-based approach where we can. So any additions to data quality is a configurable JSON approach where you have a user interface where we can edit all of these business rules. So for example, here you're looking at, you want to have a business rule where you say my formation top should be less than the total depth of your wellbore trajectory. So you're looking at not just simple data comparisons within the same data, but you're looking at against different kinds of data sets as well. That way you can do a whole subsurface characterization and apply the business quality rules on top of that. And then we also have a data weighted score. Again, these are variables depending on how strict your compliance are, but this is an example where most of the weightage is on the OSDU schema compliance and mandatory fields, and we can go through all of this. So ultimately, the data has a unique data quality score for every record before you ingest and after you ingest. So everything that you have, we can have a corresponding validation score. Okay. So here is an example where for this well record, we have all the compliance scores, and it gives you, it has a 95% accuracy, and but then it has issues with the reference data, right? So like that, you can go into every single record and you can have trusted data and you can have a quality score on all of that. And then we also have all this technical assurance is also captured as part of the manifest. Okay, and then you have this kind of a dashboard where we have the completeness for the QC report and all the validation score for all your records. So as I mentioned, every data set, the way you analyze the seismic data is different than how you look at well data and also the petrophysical interpretation, right? So we have a new set of business rules for petrophysical interpretation. In this case, we are looking at the porosity, permeability, shale volume, the lithophase, also rock quality. So not only we look at the thresholds, but also we look for the cross property relationships. So when you're looking at the data quality, you say, is there a negative correlation between porosity and water saturation? And you can expand your data quality rules, and then you can also do analyze from the data quality assessment point of view. So the summary is, for each data type, the business rules are different. So what EDI is now offering is a more comprehensive drill down into each of the data types before you ingest anything into OSDU. Okay, so here is an example where we have ingested the CPI data quality data into OSDU. Okay. Another aspect is, as OSDU is evolving, as the previous gentleman said, right, most of the conformance is on the well data. There is more on the production data and things like that. So more and more, if you want to bring in new kinds of data sets, we have a custom schema mapping where we can define new schemas and then ingest into OSDU and follow the same pattern of the OSDU format. So here is an example of how we do it. So we have a schema that you can define in a JSON format. We have a business rules validator, and once you validate, we register into OSDU. And then what we do is once we register, we do a source to target mapping using the transformer. So for example, let us say you have, for example, we were doing for a mining data set. They have drill collar, which has a depth, which has a value, and then it has the coordinate system where it is in the CRS coordinate system, and it has all the legal tags. So what we do is we can map that to a corresponding name. In this case, you will have the drill collar ID and things like that. So what we are doing is we are mapping the source data to the new schema that you have just registered, and then we can ingest into OSDU. So that is how we are introducing new kinds of schemas into OSDU. And we hope that, let us say you have an operator that has a development schema with the community, they will productionize that in the next versions of OSDU. So that is how we are bringing in new kinds of data sets into OSDU. Okay. And then we have a integrated subsurface view where we are bringing in all the data. Again, this is mainly from the data quality point of view, where we are doing all the data-driven data quality, but you also want to see the visualization where you can correlate, we can contextualize all the data and make sure the CRS is correct. The best way to do it is put it all together and visualize the data together, right? So then it's all in the same area, like all the bells. So here is one example of how we took the EDI OSDU and we expanded the custom schemas, and we have now ingested some of the mining data into OSDU. So these are some of the things where we have built a pipeline where we can ingest all the drill hole data, geology, surveys, and assays into OSDU. And then here is an example which looks pretty similar to your subsurface, but except that the definition is slightly different. So here you have a surface. And here you have a drill collar, which looks like the trajectory, but it's all shallow. And then you have all the lithology comparisons, like the borehole assays comparisons. In this case, you're looking at how the copper distribution is, or the silver distribution is, similar to how you see a correlation cross plot of all your lithologies, right? So we used a similar concept that we have, and we are applying it to mining. So all these are mining the drill holes, and we are applying here what you're seeing is the metal concentration along the drill hole. And then here we are doing a lithology comparison of all the drill holes. And then we are also bringing in the airborne geophysical, where we are taking the data from a flight, basically a flight path, and where we are using the CRS coordinates of the OSDU and bringing in back into OSDU as a schema. So here we have actually deployed a geophysical schema, and then we have attached the flight path to the schema, and then we are visualizing in the platform. And here is similar to your subsurface view. We have all the drill collars here. We have the seismic horizon, and that is how we are visualizing all the drill collars all in the platform. So pretty much what we have leveraged is the CRS coordinates, the definition that OSDU provides, the legal tags, all of that, the schema itself, and then we are applying it to the new domain, which is the mining area in this case. Okay, so again, just like your bore holes, you have the drill hole, we can navigate along the well path, along the drill hole path and things like that. The next concept, what we have is a persistent collection. Once the data is there in OSDU, now you're getting ready for consumption. So this is the persistent collection is a schema that you have in OSDU. So essentially you have analyzed like thousands of records, and now for a given set, you have a small set of data. We are taking that, we are aggregating the diverse data into one area, into one aspect. It's like a collection, it's like an encapsulation of your data. And we have the persistence where it is actually stored as a schema into OSDU. And then we have this persistent collection. And the only thing is this persistent collection will be like a transient data collection. Like, for example, you have the source data with EDI-IQ, we have ingested into OSDU. Then from there, you have created a project. Basically, you're analyzing a small set of data, and we have created a persistent collection. And now that persistent collection is actually available as a manifest for all your interpretation, Petrel and so on. Okay, so essentially you have created a trusted data set that an SME has validated, and then you're making it available for the interpretation. So now, as we go through a trusted data into OSDU, now we are getting into more of the consumption layer where we are using persistent collection as the first step. Then what we have done for one of the operators, we have leveraged, because the fiber optic data like the DTS and DAS, they are really, really dense. So what we have done is we have converted the fiber optic data into the VDS format. So essentially, now once the data is in OSDU, where we have converted the raw, what you get from the fiber optic data, we have converted into VDS, and we have used the same seismic project and the sub project, and we have landed the fiber optic data in the VDS format. And then the goal is to now you can use it for interpretation. So essentially the goal is we are now trying to see, once the data is in OSDU, how can it be used for actually getting into insights. So in this case, like a fiber is like a continuous sensor along the well. So you have data every meter, every feet, and then you're collecting the temperature and sound and acoustic signal. So it could be like vertical seismic profiling. And then what we are doing is we are taking all of the data and we are converting into VDS format. And the problem that we are trying to solve there is the fetching of the data, like the DAS data is almost like 2 to 3 terabytes a day. So we're able to quickly recover the data in a much faster format, leveraging the VDS APIs. So here is an example where the data is in OSDU. We have all the completions and the lithology. What you're seeing here is the bottom hole pressure that is also ingested into OSDU as a time series log. And then here what we are seeing is the VDS definition of your raw amplitude from the fiber optic sensing. So where we are able to leverage the data using the VDS APIs and populate all in one single contextualized visualization. So here we are looking at 1 hour of fiber optic data all in the screen that is using the same seismic project and the VDS APIs and populating here. Okay, so that is how we are leveraging. Once the data lands in OSDU, we are now getting into more like the consumption and for interpretation and insights. Okay, so I'll do a quick demo. So this is the EDI interface where we have the source data quality. So we are scanning through all the S3 bucket. So we have about 50 to 60 gigabytes of data. We can look at the segue files, for example. So we can look at the preview of these data sets. We can look at the binary header, text header, and all of these. So this is before the ingestion. What we have is we have this data quality. So here is what I mentioned, where we can scan through all the data of your seismic headers. So here we have looked at, say, for example, 56 files, and we have 95% quality score for each of the data sets that you have here. So it gives you a very detailed analysis. And as I mentioned, the business rules is something we have defined, but the compliance is up to the operator, so they can have even stricter compliance. So for example, if you don't have zonal information in your segue header, which is usually most of the cases, you can even reject it, right? So all this is configurable. So now what you have seen is a summary of all your segue form, all the source data check. You can go into details of the source data, and then you look at each file and say, for example, I can pick up this file and it gives me a score of on the each segue file. So I have a structure here. I can go in extreme detail against each of these files. So this is even before we do any kind of OSDU ingestion. So we have a very detailed analysis of all your coordinate system and everything. Once you have that, then we go into the next step, which is the seismic header analysis, where we are now looking at the byte position. So for example, here we look at any kind of, say, for example, I look at one of the 3D files here. So here I have the binary header, I have the extracted header, you have the byte positions. So here is where I can now do a sawtooth pattern and check if the pattern is there. So now this is all good. So now I say I have the finalized byte positions. Now I'm ready for ingestion, right? So then I go through the whole process of ingestion, and then I get the next set of data quality, which is on the business rules here. So if you look at the QC report, it now gives the whole summary of all your data at even different object types and all of that. It gives you all this conformance, data duplication, data thresholds, and all of that. So that is how you can look at the entire data set all together. Okay. So as to recap, right, essentially what we have done is we have done a very comprehensive analysis on your source before you do any kind of ingestion and processing. We qualify the data. Now you say how good my data is. It is good. Say, for example, I'm 80% sure my data is all good. Now I go ahead and do the full-blown data ingestion through our pipelines. And then once it's ingested into OSDU, as it is being ingested, we also look for that it is following the schema compliance and all of that. Okay. So next up is the visualization here. So here is an example of the 3D visualization. So once the data is in OSDU, we can now look at all your horizons, faults, and all of that, and you can navigate through the BDS API. So here's an example of the inline plane where I'm navigating through the APIs. So I'm leveraging the BDS API and updating the data set, right? So here you can apply different levels of detail and things like that. So we are completely leveraging the BDS APIs to do the queries once the data is into OSDU. Okay. The next step is here is where you can look at the persistent collection. So I've defined a whole bunch of projects. So now I'm getting ready for persistence, for collection, for consuming for the data. So I'm going to select a bunch of projects and export the collection. So it creates the manifest. So now I can go to the metadata search and look at the advanced. So here we look at the work product and look for the persistent collection. So this is giving you the encapsulation of all your data sets. So now I'm saying these SegWave files have been trusted, have been validated. Now you can use it for any kind of consumption. Okay, so that is what it is. Okay. The last part of the demo is the custom schema. So here I'll go to the custom schema. So I'm going to demonstrate, as I mentioned, second. So the purpose of the custom schema is, say, for example, geothermal, there is no straightforward format for that. So what we do is here we have a geothermal, like basically it has an example of all your geothermal data, which is basically start depth, end depth, and the temperature profile. So here I can select the custom schema, which is a work product here, and I can give a schema name, which I'll say geothermal. And I can describe the schema description. And I can define the schema version. So this is how the mining team has been developing with every schema that you have right now would be in a development stage. And as more and more people approve on that. So the idea of this approach is we can add more attributes and change attributes and finalize that. So here I'm generating the description here. So the reason why the description is important is for all the fields, if you don't have a proper description, then it becomes very difficult to interpret that and finalize that, right? So then I'm going to generate the schema here. So this is the schema definition. Then I'm going to validate the schema. So I'm going to select so I'm not registered yet. So I'm going to validate the schema now, right? And then I can do the registration. So that is the whole idea of how we can provide so I'm selecting the data. So now it says it is validated as to the draft 7, and I'm going to register the schema there, right? So that is the whole idea of how we can define new data types into OSDU and then ingest and start the pipeline, right? So that's in general, that is the approach how we have taken even the fiber optic data for one of the operators, and also for the mining industry, how we are using the EDI platform to accelerate the data ingestion into OSDU. Thank you.
Thank you, Sasha. Excellent presentation, a lot of information. I'll take over the screen share, but you have a question in the chat that you have a couple of minutes to address. And if anybody else has questions, please feel free to either go off mute or type them in the chat as well.
Yeah, sorry, I didn't. Yeah, so as I said, like most of the formats, especially on the seismic yeah, that's a very good point. Like, because if you don't have the decimal precision, you'll have something wrong. So yeah, so what we are doing is we are making our own humble attempt to characterize the data as much as possible. So we leverage a lot of the online repositories, the segue formats, and we have defined all these rules. There could be some rules that are missing, and that's why we have this JSON format where anybody from a user can adapt that, and then we can build on top of it. So. But that is one format that we discover and we display, and then we can have all of these. Like, how much is the strict compliance? It's up to we can be very rigid. Right now, what we do is we are a little bit lenient on the goal here in the first exercise is to identify what is wrong with your data. Now, correction of the seismic data, like denoising and things like that, we can save it as a new thing and then create a lineage out of that. So yeah.
Awesome. Thank you so much, Sashi. Yes, there are the question about recording. It will be posted on the same YouTube channel. Give me a couple weeks, please, to make sure that it's up and running, and it will be there. Feel free to kind of continue posting your questions in the chat. I will quickly go ahead and start wrapping us up. I would greatly appreciate, before I show the couple of next slides, if you could please go ahead and fill out the survey for this session. I posted the link in the chat as well. Just give us some feedback. What would you like to see in the next session? What other potential talks you'd like to see? If your company would like to present in the next webinars, I would greatly appreciate that information as well. And then just kind of wanted to showcase the upcoming events. We have the open group OSDU Summit coming up in November 3rd to November 6th in Houston. AWS will be there along with all our partners. And you can see some of the presentations and dive deep into what you saw today and talk to the company's representatives at that forum as well. So hope to see you there. And the final slide that I have is sorry, something happened to my screen. Okay, there we go, it's back. So if you'd like to volunteer to present in AWS Partner in this upcoming webinars, please shoot me email. You can reach me at ygubinov@amazon.com, or if you have any other questions about energy data insights or OSDU and AWS, feel free to use the OSDU-on-AWS@amazon.com email address and contact us. I'm tentatively planning the next session for the first quarter of 2026. I can't believe we're already talking about 2026, but time flies. And that's going to be scheduled around April or May of next year, depending on availability on the calendars. And with that, I'd like to once again thank the presenters, Kevin and Sashi, for excellent presentation during this webinar. Again, please fill out the survey. And with that, thank you very much for all the presenters attendees. I hope to see you in the OSDU face-to-face in a couple months, less than a couple months. And appreciate your feedback on the survey. Thank you again.
Yeah. Thank you all.